to my SpeedMaths and Math Electrical for you. Today we are going to discuss out one more problem on the EMF method. A 10 MVA 6.6 kV 3-phase star connected alternator gave the open circuit and short circuit test. So these are the test of the details in which we have 25, 50, 75, 100, 125 and 150. Line EMF in kV is also given as 2.4, 4.8, 6.1, 7.1, 7.6, 7.9. And the short circuit current in ampere is also given as 288, 528 and 875. So first we'll start the solution to solve this problem. Before that we'll look out what are the formulas are required to calculate for this percentage regulation by using your EMF method. So synchronous impedance already we know, open circuit voltage per phase divided by your IA short circuit current. And since it is in star connected, the IA and IL values are equal here. Synchronous reactance is given by ZS square minus RA square. And E phase formula already we know, V phase into cos phi plus IA into RA the whole square plus V phase sin phi IA into synchronous reactance the whole square. And percentage regulation is given by E phase minus V phase divided by V phase into 100. So first the given data are in kV and then in MV. So first we will convert this in terms of volt ampere and this in terms of volt. So first power rating is 100 MVA. Since it is M, so we will write 10 power 6, that is megawatt. And voltage is given in kilowatt, so we will write 10 power 3 as volt. Or you can multiply 6.6 into 10 power 3, that will become 6600 in line voltage. Now we will try to find out what is your current values which have it for IL to this given data. So VL already we know this value. So power formula is P is equal to root 3 times of VL into IL. From that IL is equal to P divided by root 3 into VL. So make students clear, when you are using your power you write it in MVA, and when you are using your line voltage express in terms of volt. That's why it is multiplied 10 power 6 and 10 power 3. On simple calculation to this we will get the value of IL as your 875.7 ampere. Now up to the previous problem, from the graph we have calculated. Now from the table we need to find out. So we will take the approximately equal to value 875 ampere. Now see this data. From this data the short circuit current is 875 ampere, for which the field excitation is 7.5 ampere. For the same field current the line EMF in kV is 6.1 kV. So short circuit current of 875, field excitation required is 75 ampere. For the same field excitation the open circuit voltage is 6.61 kV. Remaining procedure we'll see how to calculate your E phase now. So synchronous impedance is open circuit per phase divided by IASC. So since it is given as line voltage is given as 6.1, so we'll convert 6100 divided by root 3. That is the corresponding value which you are getting in your open circuit voltage is your 6.1 kV. For the current, the same current, the field excitation current is 75 ampere. The short circuit current is 875 ampere. That's what is substituted here. Now with this ZS is on simplification we'll get 4.02. Synchronous reactance, same formula, will get 4.02. So most of the case we will not get the same value, but this particular problem we are getting the same value. Now phase is given as 6.6 kV, that we are converted into volt and divided by root 3 since we need it in per phase voltage. Now we will try to substitute all the values. V phase value 3810.5 volt, cos phi, sin phi, synchronous reactance and your IL value. Now already V phase we know 3810.5 into cos phi is 0.8 and IA value, that is short circuit ampere, is 875 ampere. Armature resistance per phase is 0.15 and V phase once again 3810.5 and sin phi is 0.6. As already we explained you how to find out cos phi, from that how we can get your sin phi. So on substituting all the values of your data with this formula, we can calculate your E phase is 6616.7 volt. With that percentage regulation can be obtained with this data, and we obtain the percentage regulation as 73.6